To what? No, I'll take that up after we're done with this. Okay. First thing, let's write out what we know about ionic bonding. Okay, there are two types of bonds. Okay, and we went over ionic. Okay, anybody remember anything about an ionic bond? What'd you say? Okay, it's the transfer of electrons. So there's transfer. Okay, anything else? Very good. Okay, so it's usually, I'm just going to abbreviate metal and nonmetal. Okay, so if it's a metal and a nonmetal, the difference in electronegativity, is it large or small? Exactly. So we have, I'm going to put a EN's electronegativity, so large change in electronegativity. Okay, very good. Covalent bonds are the sharing of electrons. Okay. Okay. All right, so in a bond between two atoms that are sharing electrons, each bond has 2 electrons in it. Okay, so this bond right here, these are just model atoms. They could be, whatever here. You can have a single bond. Okay, you can have double bonds. So that means you would have 4 electrons that are shared between 2 atoms. And you can have triple bonds. Okay, and these down here, you don't have to worry too much about that. It's just showing that the more bonds you have between atoms, the stronger the bond is. Okay, and actually makes the bond shorter. That's what this is right here. And it makes it stronger, the more bonds that you have. Okay, for a covalent bond, what's happening is the orbitals that we've talked about, and the orbitals we've done electron configurations and all that, the orbitals are coming close enough in proximity to where they overlap. Okay? And when they overlap, the electrons in each of the orbitals, so here's a hydrogen with an s orbital, right? Because its electron configuration is 1s1. Okay? They get close enough in proximity that you get orbital overlap. Okay, and so they can share electrons. Okay, so this is just kind of how we could represent this. If we did our Lewis dot formula where hydrogen has 1 electron around it, so if you have 2 hydrogens, they're going to want to bond, right? So they can share electrons, and they can each have 2. Okay, hydrogen always wants to have 2, okay, to be like helium, right? Okay, and so we represent this better by just drawing a dash. So just a single line. That's how we're going to, when we draw Lewis structures and things, we won't do that today, but that right there just indicates a covalent bond. Okay, here's HCl. Okay, so here's chlorine. Okay, what group is chlorine in? Which group? Group 7. Okay, what's the common name for that group? What do we call that group? Halogens. Okay, so if you look here, we have 7 electrons around chlorine. Okay, it wants to have how many more electrons? 1, right? Okay, so it's going to want to share electrons with this hydrogen. Okay, the hydrogen wants how many? 2. So if they come close enough together and their orbitals overlap, then they can share electrons. Now hydrogen has 2 and chlorine has 8. And so we represent that. We draw it this way as well. Okay, the covalent bonding, there are 2 actually kind of subclasses under a covalent bonding. Okay, the first is nonpolar covalent bonds. Okay, these bonds are when the atoms share electrons equally. Okay, so that means that their difference in electronegativity is 0 or very small. Okay, so nonpolar covalent bonds. they have 0 difference in electronegativity, or they are hydrocarbons. So we'll talk about this in a second. Okay. If two atoms that are bonded together have identical electronegativity values, okay, this is a nonpolar bond, okay, because they're going to share those electrons in between in their bond equally. Okay, so if you think about any diatomic molecule, meaning just an atom bonded to itself, it's going to be a nonpolar covalent bond. So if you think about that, that makes sense because neither one here, they have the same electronegativity. Okay, so they're going to share the electrons in that bond evenly. Okay, going back to, because I keep using electronegativity, what's electronegativity? Anybody? Okay, it has to do with negative. Anybody? You gotta know this, Small Monday. Do what? Okay, exactly. In a bond, right? Okay, so now we're talking about bonds. Okay, so we're saying that our nonpolar covalent bonds have no difference in electronegativity. Okay, so this is what I mean by that. All right, if we have, do you mind volunteering, Stratton? Okay, so if she's a hydrogen and I'm a hydrogen, okay, and here's our bond between each other. Okay, how many electrons are in here? 2. Okay, when we share equally, that means that we both, so we're going to pull at the same strength, just barely pull. Okay, we both pull on the electrons in this bond equally. Okay, there's no shift. Okay, I'm not electronegative more than her. Okay, if I was a chlorine and she's still a hydrogen, who's more electronegative? Me. So what am I going to do? Okay, yep, hold on to it. Okay, I'm going to pull harder, right? I'm going to be winning the tug of war, and the electrons are going to be shifted, so I'm not going to be sharing equally anymore, okay? But a nonpolar, thank you, covalent bond shares equal. So that's the first one we did here. So if we have 2 hydrogens, 2 oxygens, 2 nitrogens, they share equally. That's what we call nonpolar. Okay, a hydrocarbon is also included, so you just got to remember this. Okay, hydrocarbon means anything composed of only carbon and hydrogen. Okay, the difference in electronegativity between carbon and hydrogen is very small, so we still consider them to be nonpolar. Okay, so I'll show you an example. So here's a simple one. If we had CH4, this would be a nonpolar. The bonds in this molecule would be nonpolar covalent because it is a hydrocarbon, right? Okay. So to classify under nonpolar, they have to be identical, okay? Or hydrocarbons, okay? If we had, what about this? Is that nonpolar? Okay, why? Hydrocarbon. This is one of the most missed on the exam. I'm not sure why. Students forget. Hydrocarbons are considered nonpolar. Okay, and you'll actually see this in the lab. We'll demonstrate this. Okay. So what do you think our other class is going to be? We have 2 classes, subclasses under covalent. We have nonpolar, and then we're probably going to have what? Exactly. So we have polar. Okay, one thing we forgot to mention, our covalent bonds share electrons, and these are usually bonds between what? Anybody? Between nonmetals. So that's a big difference, right? Because this is between metal and nonmetal. Okay, so these share electrons, and these are going to be nonmetals. Okay? Polar covalent bonds, I just demonstrated one when I had HCl there. Well, here's some more non-polar, sorry. So we'll learn how to draw these. You wouldn't necessarily right now know that had a triple bond there, but we'll learn how to do that. So there's some more examples of non-polar. Okay. Polar covalent bonds are not shared equally. The electrons are shifted, just like when she was the hydrogen, I was the chlorine, and I pulled harder. It's a tug-of-war kind of effect on the electrons. Okay. So polar, there is a difference in electronegativity. Okay, and once again, these are between nonmetals. Okay, the greater the difference in electronegativity, the more polar the bond is. Okay, so polarity and electronegativity, so I keep using that word polarity, it's basically the same thing, or the concept behind electronegativity. So the more electronegative that you have in the bond, the more the difference, then the more polar the bond. Okay, so those two words kind of go hand in hand. But basically you have an unsymmetrical shift or distribution of electrons when you have a polar bond. Okay, HF is a very polar bond. Okay, hydrogen has an electronegativity value of 2.1, fluorine of 4. Okay, you don't have to know those values. Okay, if you did, I'd give them to you. Okay, so the difference is 1.9. We consider this to be a pretty large difference. Okay, but keep in mind your biggest differences are going to be your ionic bonds, right? Okay, so then next would be your polar and then your non-polar. Okay, so has a difference of 1.9. It's a very polar bond. So this is a polar covalent bond. Okay, why is it not an ionic bond? Okay, so got a pretty large difference in electronegativity. How would we differentiate this from an ionic bond? Exactly, it's non-metal. So you got to look for that first. So if I give you a list of compounds, you want to classify, is it a metal and non-metal bonded, or is it non-metals bonded? Okay, so hydrogen and fluorine are both nonmetals, so you know it's got to be covalent. Okay, and then you have a difference. Hydrogen and fluorine are not the same atom, okay, and they're not hydrocarbons. Okay, so it's going to be a polar covalent bond. Okay. If you look at the electron density, this should hopefully make sense. This is not shared equal. The electrons are not shared equal, so they're being pulled closer towards the fluorine. And that's why when you look at the electron density map, you have a high density. This red area is partial negative. And that's a little partial sign. Okay, it's partial negative because electrons are negative. Okay, and so if it's pulling it closer towards itself, it's going to have more electron density. Okay, here's another one. HI has a difference of 0.4, so not near as much as our HF, but it's still two nonmetals, and there is a difference. It's not a hydrocarbon, and it's not the same atom bonded to itself. Okay? So now this will be similar. I'm going to ask you something like this on the exam. Okay? Look at these for a second, and then we're going to classify. We're going to classify each of these compounds as ionic, nonpolar covalent, or polar covalent. Okay? So look at those for just a minute and write down what you think they would be. NCl3. First thing we want to look at, the atoms, are these metals and nonmetals or nonmetals? Nonmetals. So right away we know either it's going to be polar or nonpolar. Okay. Now look at nitrogen and chlorine. Are they the same atom? Nope. Are they hydrocarbons? Nope. So they're going to be polar. Very good. All right, what about this one? Calcium and chlorine. Okay, calcium is a metal. Chlorine is a nonmetal. Ionic. Bromine. Okay. It's a nonmetal, right? Okay. It's over there on the right-hand side. It's a halogen. It's bonded to itself, so it has identical electronegativity. Therefore, it's going to be nonpolar because there's no difference in electronegativity. All right, what about this one? Potassium tribromide. Okay, everybody agree? Polar covalent. Okay, it's two nonmetals. They're on the right of the stair step, and they have a difference in electronegativity. Okay, so if there's a difference, then they're going to be polar. All right, what about this one? Rubidium. Okay, ionic. Everybody agree with that? Okay, you have a metal and a nonmetal. Typically, ionic's the easiest because it's, metal and a nonmetal. That's what you're looking for. Okay, any questions on this? Okay, I'm just going to show you a summary of what we've done, and we're not going to worry about this slide right now. It's no big deal, but try to get to the review. This just compares the two. I wouldn't worry. As far as, you know this right here. There's your ionic compounds. Here's your covalent. These are some properties that we're going to do in the lab. So you read through these, but you'll actually see these in the lab. So I'm not necessarily going to ask you to list all these on the exam or anything for Monday. But we will see how ionic compounds, because they have charges and they transfer them, that they conduct electricity. So we'll do that in lab. And then your nonpolar compounds don't. And the main thing here is this last point, that you know the difference between an ionic and a covalent compound with respect to the electronegativity. All right, here's just a little summary. So we try to classify all of these compounds as ionic or covalent. Okay, and in reality, they all have a little character of both. Okay, so this is just the way that we try to classify, so chemists can correspond and talk to each other in a certain way. But this is kind of a little just summary. So if you really understand this, then you've got a good idea of the two types of bonds. Okay, so here we have a nonpolar covalent. Here's an example. And it's going to have 0 or be a hydrocarbon, a very small difference in electronegativity. Okay, as you move along here, then you hit polar covalent. And this is where we have an intermediate. It's we do have a difference in electronegativity, but it's not as large as our ionic. Okay, I don't like putting numbers on ionic and covalent. Typically, larger than 1.9 difference is an ionic. Okay, but that is not always the case. I don't put numbers. You may have learned that before. If it's this, it's always, but that's not really true. So we just try to classify the best we can by looking at a metal and a nonmetal versus nonmetals. So here's ionic. Here's an example, and they have the largest difference. So you are going to have to kind of describe this on the exam. So be sure you know what electronegativity means, okay? And then be sure that you can tell me the differences between, so they're all really right here, between an ionic and a covalent bond. Okay? Okay. If there's anything anywhere that says Lewis structures, we didn't get there, so I don't know why we moved slow for some reason. But so if that's on this, I think it's on this practice test, yeah, number 5, it says draw the Lewis structure. Well, if you're welcome to try if you want to, but that's not going to be on this exam. So you can just skip that one if you'd like and come back to it later. Okay, here's just a little practice test. This does not mean that this looks just like the test, okay? Some students think, I'll just do this and then I'm ready. Okay, this is just some extra problems just to kind of see where you are, but please don't just use this for your means of studying. There we go. Oh, sorry. Wait. There we go. There we go. Okay, I'm going to get you started on a couple of these just to be sure everybody's okay. That first one there is just using the density equation, so hopefully everybody can do that. You're given the density, you're trying to find the mass, so you have to rearrange. Trying to get this off. Okay. All right, number 2 gives students some trouble, so I think I even put it on that little quiz thing on Blackboard, but okay. First part of number 2, let's look at that one real quick. All right, you have a subtraction, 23.24 minus 6.2. Right, so if you do that first step, what's our rule for subtraction and significant digits or decimals there? Yes, don't forget your addition subtraction rule. Okay, so many students try to do the multiplication division rule when they're doing subtraction, okay, or addition. Okay, so if you look there, okay, and you subtract that, I believe we end up with 17 point something. Okay, so what do I have to record it to? 17 point, the 10th place, exactly. So it'd be 17.0. Okay, if you do the wrong rule, then you're going to end up having the wrong answer in the end. Okay, so you've got to use addition and subtraction. Okay, the next part is the now multiplication. Okay, so what's our rule for multiplication? How many significant digits there are. So be sure you know your rules of leading and trailing and all that. But here we don't even have zeros. Okay, so we have the least number of significant digits in that part is 3, right? So we would say 34, I think it's 0.9 is what I got. All right, they both have 3. So now when we divide, we're going to end up with how many significant digits? 3. Okay, so this is just a good problem because it makes you use both rules, okay, and you see subtraction, multiplication, and division. Okay, so just don't forget those rules. Talking about in your calculator? Yeah, that's what I would do. Mm-hmm. Oh, yeah. Sorry. Okay. For number 3, let's pick one here. Y'all pick one. Which one you want to do? The first one in the column, second, or the third? Okay. So if we have a negative charge on bromine, which is not shocking, right? Because it's a halogen, and it wants to gain an electron, right, to be like the nearest noble gas. Okay, so it's a very common ion there. Okay, if we look over, let's see, we're given the neutrons is 45. Okay, so we've got a slot, and then 45 neutrons. Okay. First thing you can always do is find bromine on your periodic table and what's its atomic number. 35. And that never changes, right? That's the identity of an element. Okay. The atomic number is the number of protons. So in all of these here, that atomic number and your proton number should all be the same. right? Because the atomic number is the number of protons. So if we go over here, so that's our atomic number. Okay, our protons is 35. Okay, protons and electrons are equal unless you have a charge. Okay, so if we had 35 protons but we have a negative charge, how many electrons are we going to have? 36, right? You gained an electron. So there's 36 electrons. Okay, what's our formula for mass number? Protons plus neutrons, exactly. So you're given neutrons. There's your protons, so your mass number is 80. Yeah, that brings up a good point. Okay, mass number is always a whole number and is given to you. Okay, so, or you had to figure it out. Okay. That is the specific isotope. Okay? The atomic weight is a totally different number. That's what's on your periodic table. Yeah. And it's going to be a decimal number, and it's the weighted average of all the isotopes of that element. Yes. Exactly. Yep. If you had a positive charge, then you would subtract one. Mm-hmm. How's everybody feel with electron configuration? Feel pretty good about that? Anybody need practice with that? Okay, then we'll move on past that one. What does y'all number 6 say? It's not a naming one. I got a different, okay. Okay, yeah. No, you need, yeah. Number 5, you don't have to worry about that one for the test. Okay, number 7 is our trends. So you have a atomic radius trend, and this time it's largest to smallest. Okay, so you're going to first, in that first little line there, you're going to do the radius from largest to smallest, and then the one under it, you're going to put the most electronegative to the least electronegative. What you're going to find is they're opposites of each other when you do the trend there. Okay. Be sure we get everything from today. Look down at number 8. All right. It says put a square around the nonpolar covalent compound. Oh, sorry. The first thing says circle the ionic compounds. Okay. So which ones are we going to circle? Metal and a non-metal, right? Metal and a non-metal. Put a square around non-polar covalent. Okay. This is the only one I see. Everybody agree with that? Doesn't really look like a square, but. All right. And underline polar covalent. So non-metals with different electronegativity. Did I go too fast? Everybody got it? Okay, number 9, you'll have a few like this. So the exam where, I give you a piece of information and you use the periodic table. Of course, you'll be given a periodic table. You'll also be given conversion factors. Okay, on this little practice sheet, I didn't do a lot of converting. Okay, there's this big long worksheet on here that looks like this. You may have not done it yet, but I would definitely do it before the exam. Okay, but I will also give you the conversion sheet, so you don't have to memorize any conversions or whatever. You just have to know how to use it. Okay? All right, so number 9. We're going to have quite a few like this, where you have to, it's going to just kind of test you on what you know about the periodic table. So do you know what a halogen is? I may say, what halogen is in row 3? Well, you have to know that a halogen's in group 7, right? Okay, so it's just kind of using your knowledge. Okay, what element's mass number is 138 and has 82 neutrons. Okay, so how can we go about finding out what element this is? Perfect. And you get what? 56, which matches up with what on the periodic table? Exactly. Okay. One common mistake, so I want to show this real fast, is to forget. So look at number that, or whatever it is, I don't have a number by it. What element has 4 valence electrons and is in the second period of the table? Okay. First of all, you have to know valence electrons correspond with the group, right? So there's our group 4. Everybody knows that. Okay, don't forget, this is the first row. I don't know if I pointed at it, but hydrogen and helium, that's the first period. Okay, for some reason students accidentally want to start here. Okay, so that's the first one. This is the second. So if you go over, what's it going to be? Carbon. Okay, don't forget about that first period there. Don't skip it. I can't remember which one I print out for this one. It's not going to be an issue for you because I'll just give you the symbol and you match it up. When we start naming, I'll give you a periodic table that has the names on it so that you can, you want to start, learning them, but I don't know why periodic tables nowadays, they don't even put the names on them. So it's hard to learn them if you don't see them all the time. Okay. What halogen, so there you go, that's quizzing you. What's a halogen? Okay, I could have said what noble gas. You have to know noble gas is in group 8. Has the smallest atomic radius. Exactly, fluorine. Okay, what if I asked you what halogen is the most electronegative? Fluorine. Yep, exactly. Okay, so that's just kind of gives you an idea of what I'll be. I don't know where it went, but there was a little. Here it is. Okay, this was one of the little worksheets that you may or may not have done if you didn't do the extra credit stuff. But it's a good one too. So it helps with, there's some more, write the symbol for the following elements. So what we just did, kind of something like that. So all these are good problems, more electron configurations to practice. Trying to think what else. And don't forget to look back at the very end of chapter 1. We talked a little bit about specific heat. Okay, don't forget about that. Q equals MC change of T. That's one of the things students forget to look back over. Okay. Converting your Fahrenheit Celsius. You need to know that equation. I think that was, had a few of those on OWL, didn't you, to do? I don't remember if I put the Kelvin one on there or not. Okay. Yeah, so you got practice with those. Can't think of anything else not to forget about. The trends. Yep. That's about it. There's an outline on Blackboard too. If it says anything, sometimes we get to Lewis structures and sometimes we get to naming. We didn't get to those, so that's not going to be on the first test. So we'll catch up with that. But yes, any worksheet that I post on Blackboard for you to work and to turn in for extra credit, I will post probably immediately after class. I'll post the answer so you can be sure that you got it right and that you understand it. Let's see what time it is. Okay, we still have plenty of time to review, so you may want to finish this up. Okay, does anybody want me to pull up one of the worksheets up here, like the quiz? Has everybody done those? You can try to work those. Any questions at all? Yes. The worksheets, yeah, there's 3. Yep. Yeah, the chapter 1 worksheet that has all the converting on it. And then the one that says quiz or whatever. Yep. Actually, yeah, there's just two because the Lewis structures we hadn't gotten to. Yep. All right, I'm going to pull up these worksheets. You can work on those. Okay. Just a reminder, okay, how many of you did not finish your OWL on time? Okay, so everybody else knew. Every time we have an exam, it's going to be due the class before the exam. Okay? The reason I do that is so that you don't wait until the night before the exam to try to do it all and come up with questions, and then it's 11 o'clock and I'm sleeping, so I'm not going to be able to answer you. Okay? So it's for you to be able to come in here today and ask. That's the point. Okay, the extra credit. So we didn't get, so it kind of was confusing because we didn't get through the whole unit or whatever. Okay, if you have that, so I'm going to go through and call names, and I'll put a +5 by your exam grade. Okay, that's a big bonus because your exams are worth 60%. So I would suggest doing them not only for the bonus points, but for the test because you need to know how to do all those problems. So, but I'll do that now. I would suggest not leaving and working on problems. I'm going to pull up worksheets. Okay, how many of you did the worksheets for extra credit? Okay, awesome. Okay, so I'm going to call you up, and you can ask me. This is the time to ask me whatever questions that you have besides I can't tell you exactly what's going to be on the test. Yes? Okay. Yes, or to get the, yes. So you can take the atomic number, the protons, yeah, and subtract it from the mass number to get the neutrons. Yep. Okay, density is always grams per milliliter. Yep. Okay. All right. Let me pull up the worksheets if anybody wants to. What do y'all feel like you're the most fuzzy on? I've got to study the most on. Trends? Really? That awesome. Okay, did you work there's a trend question on that practice test, so I would try to work that with the atomic, or the radius. It's the biggest what? Yeah. Yep, and I can review that here in a second. Let's see. What am I looking for? Yeah, so this homework here, this Lewis structure, that'll be for the next unit, so I'll try to move it over. All right, did everybody get D right? Which one of these represents isotope? You got to know, first of all, what an isotope is. Anybody, what'd y'all put for D? 1, 2, 3, or 4? Okay, put 4. Put 2. Okay, an isotope is the same element. Okay, so all these are different. So it's the same element, but it has a different mass number. So remember that mass number is the number that's up top. So this one's chlorine 37, is what we'd call it, and this one's chlorine 39. Okay. right, so we already did, I think, A. I think I put it on the quiz and the practice test, yeah. Okay, so do B, see what you got, or if you already have it. Okay, B there, and number 4. Those are both, we'll go over those in a minute. All right, I'm going to call up people for the bonus. Okay. How long did it take y'all to do OWL once you got the hang of it? Not that long? Did y'all find it pretty? And you had to. Okay.
So what happens when you
It's just a completion grade, so you would have to. I think it makes you just start it over. Yeah. Yeah. If it told you, just answer 2. Yeah. All right, Joshua. Just going to start calling up. If you've got it, just come on up here. Joshua, Ellie, and Lawson.
Did that look right to you? Is that what you're asking for, or am I completely off?
We'll go over that one just in a minute. That's a good one to bring up. That's one of the most missed. Yep, thank you.
I have 2 questions. How did
Okay.
you do this one again?
Okay, those are when you fill in, so that'll take me a while to show you. Can I show you after I
Yeah,
go around? Okay.
There was one. Yeah, this
Okay.
one.
Okay, to get the full point, you got to do all of them.
Okay.
So, and show all of your work. Okay.
Okay.
But this time I'll give you like a +2 for it, but you have to show all your work too. I forgot to mention that.
No, that's
All right, Lawson. No. Okay, Frazier, Elizabeth, Jonathan. Someone just brought up a good problem we need to do, so we'll do that in a minute. Okay, Frazier, Elizabeth,
I had to
Jonathan.
do it on like 3 different sheets of paper for the first one.
Okay. Okay. Joshua, what sheet was that from? Was that the quiz one? On the quiz? All right. Jonathan, William, Corey, Russell. Okay. Okay, nobody else has Jonathan, William, Corey, Russell, Stratton, Connell, Devin. Bonus? Anybody? All right, Lindsay, Tanisha, Hannah, Ashley. Okay, we got all of them done. Okay, thank you, ma'am. Okay, thank you. Is that your work for those? Okay, great. Thank you. Okay. John? Cassidy, Connie, Jake, Haley, Anthony. Anthony, right?
Yes, ma'am.
Okay. Thank you. Anthony. All right, Haley. good. Thank you. Haley. Alright. Now watch those significant digits on those. If you start with 3, you got to have 3 there. So just pay attention to those. Yeah, and next time I'll give you credit. This time you got to show me your work for those. Okay. Another thing, show all your work on the exam as well as for the bonus. So it's fine today because I didn't mention it, but if you did the bonus, I need to see that you don't just need to put an answer. I want to see your work if it's a math problem or whatever. So, okay, Himanji, Blake, Samuel, Sean. Thank you, ma'am.
Structures on the next.
Yes. Yes, we didn't quite get there. Good deal. Thank you. Wait, and you, Sean? Okay. Just make sure I got you by the right. Tanner, Abdullah, Joey, Catherine, James. All right, what'd y'all get for 3B? Okay. How many significant digits do you end up with? 2, right? Negative 3.0. You got to put that 0 there because you have to go out to the 10th place. Okay, yeah, just next time be sure you show me all the work. Yeah. Thank you. And you were Tanner? Okay. Gotcha. Okay, yeah, you don't have to do those on the test. Okay. Okay, while I'm thinking of it, keep thinking of things to tell you. On the exam, and typically even in lab, I'd like for you to use pencils. I haven't mentioned it to this class because I was going to see how neat your work was when it was turned in. Okay, some of your labs look like chicken scratch and stuff's all over and you've erased, and typically the best lab practice is to use a pencil so that you don't have, squigglies and stuff everywhere. But I know everybody likes pens, so I haven't said anything. But for the exam, you need to be clear, you need to show me your work, and even, circle your answers. You don't have to do that, but you got to remember your units. Be sure you report to the right significant digits. And I don't want to be chasing all over the exam to try to find your answer and looking under just a bunch of scratch under a pen. Okay, so please use a pencil and bring the calculator that you've been using so that you know how to use it. You don't get in here and punch it in and all these calculators are different and get wrong answers, especially when you're using exponents. Okay. Where was that? Joey, Catherine, James, Jared, Morgan, Layla. Anybody? Joey, Catherine, James, Jared, Morgan, Layla? All right, Christopher, Darby, Nick. Okay, that's fine. Okay, yeah, just be sure you show me how you got those answers next time. Thank you. Okay. Thank you. Okay, if you look up here at number 4, okay, we're going to find protons, neutrons, and electrons. Okay, which number here The superscript or the subscript is number of protons. The subscript, right? So protons would be 52. Okay, neutrons, how many neutrons do we have? Back to your question right there. You take 128 minus 52, which is 76. Okay, you have a negative 2 charge. So how many electrons do you have? 54. Yeah. Remember, protons and electrons are equal except for when you have a charge. So you just add 2 there. All right, what about for iridium? How many protons? 77. How many electrons? 77, right? They're equal because it's neutral. Okay, how many neutrons? What'd you say? 116. You take 193 minus 77. Very good. Okay. 5C is one of the most missed, but we'll do all 3 of these to be sure. Okay. We want to write the symbol for the neutral element. Okay, the mass number is 192, which that doesn't really tell us anything as far as on the periodic table, right? Because the mass number doesn't come from there. Okay, but we have the number of neutrons is 116. Okay, so if we take 192 minus 116, what do we get? You get 76, which matches up with which element? Yeah, so you have to put the symbol, so osmium, so OS would be the answer there. Whoop. I don't know what that is, but oh well. Okay. There are 52 electrons in this neutral atom. If it's neutral, it has 52 electrons. How many protons does it have? 52, which is the identity of the element, which makes it what? Yep, tellurium. Okay, this one's the hardest one. Okay. It forms a cation. Okay, cation means that it lost electrons, right? Okay. Once it loses those 4 electrons, it has 78 electrons. So what element is this? It forms a cation having 78. So 78 means that's how many after it forms the cation. Okay, that is right. I'm going to show it on here. Okay. If we go to 78, we're at platinum, right? Okay, but that's not what it says. It says it formed 78 after it lost 4. So how many, we need to move over 4 spaces from 78. Do we need to go that way or do we need to go this way? This way, right? 1, 2, 3, 4 lands on lead. So think about it. PB with a 4 plus charge, okay, it would have 78 electrons. I'm not sure what you're asking. Yeah, exactly. We lost 4 to give us 78. But a lot of people write platinum. It's not platinum because platinum would be neutral at 78. But yeah, start here. Right. Yeah, I know. Okay. I'm going to do one more electron configuration because I had a question on that. I don't know what that's doing. All right, we're going to do A here. All right, the first thing you're going to do is you have to come up with the electron configuration. All right. I'm going to do the full thing. I will tell you whether or not you can do the shorthand. Okay, so if I say in the directions you may use shorthand, then you're welcome to do that. But we're going to do the full thing here. All right, so you find calcium, but it has a 2+ charge. So what does that mean? It lost 2 electrons, so now it's going to be isoelectronic with what? Argon. So really, it's still calcium 2+, but you're drawing the configuration for neutral argon. Okay? So it lost 2 electrons. I'll go ahead and, I don't know why it keeps doing that, but. Okay, so we have 1s2, 2s2, 2p6, 3s2, 3p6. Okay? Had it been calcium neutral, what would the configuration be? You would add 4s2, right? Okay, so this is equivalent to the configuration for argon. Okay, so we have our energy. Don't forget to label. Yes? Yeah, on something like that, I would probably have you write the whole thing and not let you do the shorthand. Yeah. Okay. The reason on this that I wrote it all out, you cannot shorthand these. That's a mistake students do on the test. You have to show all of them. Okay, you can't just go up to arg or whatever and just put the last, whatever electrons. Okay, so energy's going up. We start from lowest to highest. Fortunately, we're able to do this because we've already written it from lowest to highest because that's how the periodic table was designed. So we can go like this. And each time we go up, we're going up in energy. Okay, so all we're doing is placing. So here's 2 electrons. There they are. Here's 2 more. There they are. We fill in our 6. I went up in energy. It's hard to tell. Is that showing up on there too? Yeah. Let me get rid of it. 2, 3. Okay, remember, this thing out of my way. Sorry. I don't know why. It's on there. Okay. And that is up in energy, that last one, even though it doesn't look like it too much. Okay, remember, if you don't have a full shell, so here we have a full orbital shell, right? Our last orbitals, everything's full, so this is stable. Okay. If you don't, you have to fill each orbital singly and then go back and pair them up. Okay, the electrons would rather be in that orbital alone than be paired. Okay? So if you only had 4 electrons there, you would put 1 in each and then go back and fill one of them up with 2. Okay? So all this is just an energy orbital representation of your configuration. All you're doing is taking the configuration and putting it in to this kind of graph or chart, okay, and showing the electrons. The arrows are the electrons. So when you add up your electrons, your arrows, it should equal the number you would add up if you added up all those superscripts. And that should also equal how many, electrons for that atom that you came up with. Okay? Questions? Good? Okay. I didn't bring my schedule down here. I can't remember. Does anybody have their syllabus? I don't know what that is. If we have lab on, check. There it is. What's today? The 9th? Is that right? 10th. Okay, yeah, I think I did that on purpose. So a lot of times some students take longer on the exam, so not always, but I try not to have lab after an exam, because if you need an extra few minutes, then you're going to be late for lab. So we don't have lab on Monday for that reason, so that if people that need extra time don't feel rushed. And I typically let you stay maybe 20 minutes or so, about over if you need it. No, I'm not saying it's going to be this long test, everybody's going to need it, but some people do. So, yeah, I don't want you to feel rushed. All right, if you have any other questions, ask me. Yes. There may be some, but it's not going to be a big portion. You know, I told you about knowing electronegativity, know what that means, know the difference between ionic, covalent, but there's not like, you know, definition type, you know, stuff. Yep. Have a good day. See you on Monday. Everybody come ace the test on Monday. Have a good weekend. Hey.
I have one more question. The radius, the atomic radius, when moving, I know when moving top to bottom, you're increasing, left to right, you're decreasing. I'm not at, since these are in such an order, I don't know, do you follow it? Like reading first, and then once you get one below it?
Okay.
I'm not sure how to read it.
Okay, so you
In
went
order, that's all.
over and found. Okay, so you started that one, right? Okay, and then. Yeah, so what you want to think of is like these are polar opposites. So this is smallest, this is largest. So whatever is further over here, yes. So you would start there, and then as you move across, then you hit. What do we hit next? This one.
SE or T.
Yes. So you hit that first,
Oh, okay.
and then go up. Yes, because that's closer to here than that is. Does that make sense? Yep. So you hit that, then go up.
What if you're up here first? Say the first one's zinc.
Mm-hmm.
Would you move back down here and go up? Or would that be this?
It would be this one. Yes. Whatever is closest to over here is
And
the.
then that one because it's lower.
Yep. So if it was zinc, and then it would be that one because it's further away from up high. So yeah. So the lower and the further over here
Okay.
is larger.
Okay.
Does that help?
Yeah.
Okay.
I think so. Thank you.
Okay. You're welcome. Yes. You were next. Yes. Yes. All of the makeup stuff you can get up to the half credit after the deadline. So I'll go upstairs and check and make sure it's still opened for you, but you can do it and get half credit for it. Yep. Uh-huh.
And I was just like, I was going to let you know.
Okay.
that
Okay. All right. Let me get you. What's your name?
Morgan Terry.
Gotcha. We'll start learning names shortly. For some reason, I had you here. So, I don't know.
I was
Let's see.
Oh.
Oh. You're welcome. Y'all have a good day.